All right, this video is to help you out with this particular question here. So let's try and attempt to solve that one. Okay, so we have a water truck scenario and the tank is transparent. So Venice notices that after coming to a complete stop, the water level with respect to the ground varies sinusoidally, and this is at the front end of the tank, right? So if something varies sinusoidally, you know that there's a repeating pattern to it. So particularly when we look at the front of this water truck. So the idea is that if you come to a complete stop, the water will swing back and forth, right? So if you just look at this front end here, the water level will go down and then up, down and up. Obviously not indefinitely, but it can be observed at first as being having a repeating pattern. The first time she notices the water level at its highest point is 2.7 seconds after stopping. So interesting here. The first time that the water level is at the highest point, so we know that, right? The first instance of a particular time is, first of all, we're told at the highest point, and it's 2.7 seconds after stopping. So that is a clue there. Those go together. So at the time of 2.7 will go together with the highest point, which we will find out in a bit. Then we're told that the water level reaches a minimum height of 6 feet above ground. That is another clue. So again, the water level is with respect to the ground. If it had just said the water level in the tank, the bottom would probably be 0 and the top would be, in this case, 4, right? So keep that in mind. It's with respect to the ground. So we know that, and it's verified here by our diagram. Let's continue. It takes 1.2 seconds for the water level to return to its original position, in brackets 1 cycle. That right there is our period. Our period is just given. We don't have to figure it out. It's not like this is from the highest to the lowest, right, which would be half a period. No, this is telling us that if you were to look at the starting at the highest, for it to get back to the highest, this is 1.2 right here. It's 1.2. So we know that our period is 1.2 seconds. And the period, remember, is the x units, the amount of x units that go by for something to repeat. So we also know in us retrieving the period from the question, and it's in time in seconds, we also know that our x-axis, if we were to graph this, would be represented by time in seconds. Okay, so we've got our period, we've got a whole bunch of information. Let's see if we can do this. It says determine the sinusoidal regression that models the situation. Show your work. You may use the table below, so we will probably do that. So the first thing that I would recommend is come up with your max, your mid, and your min. Come up with these three numbers that go along the y-axis. And for me, this is the lowest here. This is the min. And this is the max. Okay. So the min would be 6, right? So 6 feet off the ground. That's the lowest water level. And then to go from the min, this is our min, to the max, we're told based on this graph that that's another 4 feet up. So from here to here would be 4 feet in addition to the 6. So this is 10 feet here. Okay, so it doesn't give us a midline here. We'll figure it out. So to get the midline here, all we do is 10 plus 6 divided by 2. Make sure you do this in brackets. So 10 plus 6 is 16 divided by 2. And that in turn gives us 8 feet. And just make sure 6 to 8 is 2. So we know that our amplitude, I should write in here. Sorry, I'm going to put points in there. But this is 2 and this is 2, right? From 8 to 2. So you have to make sure that there's an equal distance between those three lines. Okay, so now we're good. We've got our y values figured out. All right, so now we need to figure our x values. You need to somehow get an indication of a starting point. Where do you start? Where in terms of the three lines? And also at what time? Sometimes it's time zero, sometimes it's a few seconds in. So you almost are starting a little later in the action, right? That's when you observe something. And it says 2.7 seconds after stopping, you're at the highest point. Okay, so that means that you'll be. Hey, how's it going? All right, sorry about the interruption. There we go. Continue. I'm doing this just before summer break, and the idea is to have a QR code that links to this video in your booklet. So that's why I'm doing that. The student come by and just drop off things. So we've got our three heights. Now we need to figure out our x value. So 2.7, we're at the highest. They have to tell you where on the three lines you're going to start. We're over here. So that means that this is 2.7. Okay. Now, there's a couple ways you can do this. I probably will have explained it to you in various ways, but one thing we know for sure is that to come back to the highest point over here, okay, it will be a whole period that has gone by, 1.2 seconds. So you can actually say, you can actually add 1.2 to this, and that will give you 3.9. Okay, so back up here that it'll be 3.9 seconds from wherever we started. Whenever zero is, you observed it at 2.7, 3.9, it will be back there. So now we have the task to fill out these other 3 points here. Okay, because you need 5 points within a cycle. And how do you do this? I usually like the X scale. So I know that it's a quarter of a period for me to go from one of these lines to the other. So I take my period, I divide it by 4, and that gives me 0.3 seconds. And so you add 0.3 every time. This would be 3, this would be 3.3, 3.6, and see how you can verify that you're doing things right by adding the period right away. In this case, they gave it to us. So here we have everything we need to come up with our points now. So here we go. 2.7, 3, 3.3, 3.6. Just be careful when you write down numbers. Don't rush, because then you might type in a different number when it's time to type this in. And then our heights, we're at 10, 8, 10, 8, 6, back to 8, back to 10. Okay, so this is how you would enter that. And then we put this into L1. This goes into L2. We'll go stat, calc, sin reg. Okay, sinusoidal regression. So let's go ahead and do that. How about you do it? I'll meet you after in a few seconds. Now I'm going to add that to the video after all. So I'm going to go stat, edit. Never mind all of this. I'm just going to clear everything. 2.7, 3, 3.3, 3.6, 3.9. And then I'm going to go 10, 8, 6, 8, 10. And let's run this sinusoidal regression. Alpha trace y1, put this into y1. Make sure your calculator is set to radians, and then hit enter. And here you go. There's an interesting value here that I don't want you to ever misread. Okay, this is essentially 0 for us. It's -1 times 10 to the -13. We do not care about it in this course. Okay, so it'll be 2 sine of 5.223, and this would be 6 essentially. 236x, and then it's basically 0, so you can just do this plus 8. That is the equation here. Okay, and so let's move on with the rest. You should be able to graph this. Let this guide you, right? For the window, if you go from -1 to, let's say, 5, that'll be good of an x value min and max, and then y min, you get as low as 6. I'm going to go 5. No, I want to see the x-axis. So I'm going to go -1. And then y max, it goes high as 10. I'll go 11. And there it is. Okay. All right. Determine the initial water level just before applying the brakes. So the idea is that it's going to sit at the midline, the water, as you're driving, and then you slam the brakes. So what was it at the very beginning? The y-intercept is what they're asking us for. So we'll go y2. You got to watch out for this one. No, sorry. There's several ways of doing this, but I'm going to go second trace 1, x is equal to 0. Okay, second trace 1 times 0, and we are at 8. Okay, and so you can answer like this as long as you put feet down. That's what it is. You're at 8 feet. And so it would make sense because when you're driving, more or less, it stays at the midline. Okay, not at the very beginning, but once you have a consistent speed. So how many times does the water reach the lowest water level within the first 7 seconds? Couple ways you can do this. I think what I'm going to do is I will find that point, second trace, and we're given the time, right? So I'll go 7 seconds. So second trace 1, enter 7 seconds. I can't because my window doesn't show as much. So change the X max to, let's say, 8 and regraph it. Then find that point. And here it is. And so what does it ask? The lowest water level within the first 7 seconds. So you can just count, right? So from time 0, it's like 1, 2, 3, 4, 5, and it actually, this would be included because that is slightly over, right? So 1, 2, 3, 4, 5, 6, 6 times. State the domain and range of the water level returns back to its mid-level after 25 seconds. So the idea here is that after 25 seconds, it stops, like there will be no sinusoidal anymore. So my domain is 0 to 25, and then my range, you might be tempted to say, hey, it stops at 8, that's what it is. No, it gets as low as 6 and as high as 10 throughout my domain, right? So if this is your graph, right, it stops here. So you're saying from 0 to 25, but when it comes to the y values, it gets as low as 6 and as high as 10, right? So this is my range, this is my domain. And there you have it. That was the question. Hope this helped you.